it says you don't want to wait 50 years to buy your new laptop. So you sign up for a credit card that charges 19% annual percentage rate, compounded monthly, and you charge $1,100 to purchase the laptop. So it says, circle a formula that's appropriate to use in the situation. Well, remember when we start this problem here, that we need to look for keywords in this sentence, or in this problem. And the key word in this problem is compounded monthly. Once we see compounded monthly, that's going to tell us which equation to use, and it's going to be this equation right here. The reason that we're using that equation is because that equation would be annually, semi-annually, monthly, quarterly, even daily. That's when we use that formula. Once we determine which formula to use, then we want to fill in the things that we know about this problem. And one of the things that we see is that our amount that we're going to start with is going to be $1,100 to purchase that laptop. Our credit card charges 19% APR. That's our rate. And remember, this one's a percent. Unlike some of the previous problems, this one's a percent. We need to move the decimal point. Convert it to a decimal. So I'm going to move it to the left. So this is going to be 0.19. The compounded monthly, like I said, are important words there. Oh, we're thinking, how many months in a year? Well, there's 12 months in a year. And then it says, if you make no payments on your debt for 3 years, how much money do we owe the credit card company? So let's use 3. Again, if we pick the right formula, then we've got it made. Because we're going to fill it in. 1,100 times 1 plus 0.19 divided by 12 to the 12 times 3. So we pull out our calculator, and we've got 1,100 times 1 plus 0.19 divided by 12, close the parentheses, to the, and if you have an old calculator, put parentheses right now, 12 times 3. If you have a newer calculator, you don't need to put the parentheses, but if you have an old calculator, you need to put the parentheses. And when we hit enter, we get our number here, and we're going to round to the nearest cent for this one. So in 3 years, what's going to happen is that we are going to owe $1,936. $1,936. When we round, we're going to look at the 7. Determined to round that to, which is going to be 3. Well, part C. Determine algebraically how long it will take for our debt to reach 3,000. So we want to show the setup of the model and all the steps that lead to our solution, and we're going to round to the nearest 1,000. So same information. So we can keep all of that information from part B, with the exception of the time. Because now what we're trying to figure out is, well, what is our time? That's what we're trying to figure out. So we're still going to have the 1,100. We're still going to have the 1 plus 0.19 divided by 12. But this is going to be to the 12t now. And what we're wondering is, well, how long will it take us to owe $3,000? And once again, isolate. We have to isolate. So we're going to start by dividing by 1100. And when we divide by 1100, this cancels out. It's probably not going to be a pretty number, but we'll try it. 3,000 divided by 1100. And we get this big long decimal. But we can convert this to a fraction to make it a little bit easier. Otherwise, you have to use this entire decimal. If you want to write down that entire decimal all the time, that's fine with me. But we can go math and enter, and it will convert it to a fraction, which will make it a little bit easier to solve with. So 2.7272727 simplifies to be 30 over 11. So we've got 30 over 11 equals the 1 plus 0.19 divided by 12 to the 12t. And eventually what we're trying to figure out is, well, what does time equal? Time is an exponent, so eventually we're going to have to use a logarithm. And then one thing that I want to see is, can we rewrite this a little bit? And the answer might be yes and it might be no. If we get a big long decimal, we're just going to leave it as is. But let's try it. 1 plus 0.19 divided by 12. And we're out of luck on this. I'm just going to leave it as 1 plus 0.19 to the 12. If you round this, you will have a rounding error in the end. That's why you don't want to round it. So that leads us to the fact that we're going to have to put in a log on the left, and we have to put in a log on the right. It's going to be the log of 30 over 11 equals the log of 1 plus 0.19 divided by 12 to the 12t. And like many of the problems on this packet, we have to use the power property. And what the power property says is, we can take this exponent and we can write it up front. That's how we can solve. We can't solve for the variable when it's an exponent. But if we can get it out of the exponent position, so now it's 12t times the log of 1 plus 0.19 divided by 12. And over here on the other side, we still have the log of 30/11. We want to solve for t. And now we can do it. And what we're going to do, it's 12t times the logarithm. So we're going to divide by the log of 1 plus 0.19 divided by 12. And if we divide this side by that, we're going to divide this side by this. 1 plus 0.19 divided by 12. So we're going to type it in. Log of 30/11. Close the parentheses. Divided by the log of 1 plus 0.19 divided by 12. I'm going to get this big long decimal there. I'm going to write down a number, but we're going to have to use this number again. 63.866 is what I'm going to write down. 63.866 equals 12t. And now that we've got that, it's 12 times t. We're going to divide by 12. And we pull back up our calculator. We already have that 63.866 in our calculator. Dividing by 12 and enter is going to give us the number we're going to work with. Again, what we're trying to find is how many years is it going to take Well, how many years it's going to take is going to be 5, wrong color, 3, 2, we're going to look at 1, 2, 3, we're going to look at this 2 to determine what to do to that. But since that 2, that third 2 is less than 5, we're going to leave that second 2, which is going to take 5.322 years.